Yeah, so good evening, students. We are moving to the session number 2, student, of the revision of this particular chapter. Okay? Yeah. Okay, so what we need to cover more from this chapter? We need to cover anti-rusting and rancidity topic as well as that particular balancing, student. Okay, is Ponnappa here? Ponnappa not there. Rujuta is also not there. Huh? Okay, students. So let's have a quick some two MCQs from the yesterday session. Which of the following pairs will have displacement reaction? Which of the following will have displacement reaction, student? FeSO4 plus Cu, AgNO3 plus Cu, CuSO4 plus Ag, NaCl plus Cu. Okay. So yes, Harshini, right answer. Narendran, right answer. Megha, right answer. Tanish, right answer. Maya, right answer. Come on, others. Aparna, very good, right answer. Come on, Devansh, Karthik. Come on, students. So displacement reaction. Yesterday we have seen five types of reaction: combination, decomposition, displacement, double displacement, redox reaction. Okay, displacement. We had a very easy shortcut. Please send cats, monkeys, and zebras in only packages made of silver, gold, and platinum. Yes, very good, Karthik. Okay. So obviously, sir, copper is more reactive than silver. This will displace it, and hence only this reaction will work. Option B is the right answer. Okay. Yes. Which among the following is a double displacement?
Sir, what is the answer?
Answer is option number B. B. Silver nitrate solution plus copper metal. Which among the following is a double displacement reaction? Yes, Ponnappa is joining. Good. Megha, right answer. Narendran, right answer. Harshini, right answer. Maya, right answer. Aparna, very good student. Shayan, right answer. Double displacement, exchange of ions. Exchange of ions. Yes, Tanish, right answer. Shrugal, right answer. Okay. So obviously, this is a double displacement, student. This one is a displacement reaction. Element and a compound. Okay. It's a displacement. It's a combination reaction. What type of reaction is this, Harshini? What type of reaction is this, beta?
Sir, it's exothermic and redox
Yeah, so
also.
exothermic, right answer. Okay, redox reaction.
Redox.
Very good. Redox reaction. Okay, right answer, student. Okay, so first of all, she is telling sir methane, the gas which we use at our home, and combustion is happening. So definitely some large amount of heat will be coming. That's the reason she said exothermic. Okay, but again, so if you I want to classify only among the five types, so you can see this particular thing is a redox reaction. Redox reaction. Okay, yeah. So some students, you have some doubt, right? Yesterday, even I have seen that. Yesterday, I asked you whether all the combination reactions can be classified into redox reaction, like C plus O2. Definitely, it's a combination reaction, like Zn plus HCl. You see, displacement reaction. Zn is more than hydrogen. ZnCl2 plus H2. It's a displacement reaction. Yeah. So one question, what one student asked, sir, calcium hydroxide plus what did you ask, student? CO2, CaCO3 plus something like H2O. Okay. Now, sir, this is combination reaction. You can also call it as a redox reaction. This is displacement reaction. You can also call it as a redox reaction. This is not the redox reaction, student. This is not the redox reaction. Either this or this also. Why, sir? How to classify who is redox reaction and who is not redox reaction? Okay, so this is what the trick, student. Element plus element, it is a redox reaction. You see, hydrogen is an element, oxygen is an element. When both the elements, you can call it as a combination reaction also, redox reaction also. Element plus compound. You see, this is an element. This is a compound, carbon monoxide. So again, here you can call it as a combination reaction. You can call it as a redox reaction. But you see here, student, compound plus compound, CaO plus CO2, CaCO3. It's a only combination reaction, but not redox reaction. Okay. So can all the combination reactions be a redox reaction? The answer is 95% time it is right. 5% no. Where it is no, generally where it is no, it is at the two compounds. Whenever we are mixing with two compounds, it's not the, yes, Narendra, right answer. It's not the redox reaction. Okay. Narendran, so can you say that this particular thing is no, student? I don't think so. So can we call it as a double displacement, student? Can we call it as a
Not
double?
this. I'm talking about compound plus compound.
Compound plus compound. Yeah, you see, compound plus compound, it may be double displacement, but you see, this is compound plus compound. It's a combination reaction. Okay, it's a combination reaction. So every combination reaction is not a redox reaction. Exclusively compound plus compound, whenever I am mixing, it's not a redox reaction. Yeah, so best example. So whenever you see compound plus compound is again double displacement. Double displacement also is not a redox reaction. So this is what I think Narendran want to say. Okay, so double displacement is also not a redox reaction. Student, you all know double displacement. You see here, so let us go to double displacement directly. Yeah, you see here, student, compound plus compound, you will not, so you can call it as a double displacement reaction, but it is not a redox reaction. Okay, it's not a redox reaction, student. And you can also see from here, sir, it's not redox. Why? Because you see Ag plus 1, NO3 minus 1, Na plus 1, Cl minus 1. Here also, Na plus 1, you see, is there any change in oxidation state? No. Is there any change in oxidation state? No. Is there any change in oxidation state? No. Is there any change in oxidation state? Oxidation state means charge beta. So no. So double displacement reaction itself, I can directly say it's not a redox reaction. Redox reaction matlab, there should be some change in oxygen. If it is plus 1, it should be either 0 or something else. Okay. So in that way, so this is one doubt what some students raise. Sir, every displacement reaction is a redox reaction. Every displacement, yes, obviously. You see, displacement reaction means element plus compound. Zn plus HCl. Element plus compound, element, compound. So definitely it's a redox reaction, student. Redox reaction as well as displacement reaction. Okay. Again, chemistry is full of exceptions. 1% exception. There will be some or some other compound. You see, yeah, yesterday one of the students also asked me this question, student. Sir, if I mix gold with concentrated things, like all our things, you see in your class 10, we are all concentrated on dilute acid because most of the things are the practical way. You are doing it in your laboratory. That is what your basic teaching style is. So we are not going to use concentrated at all in your lab. We are going to use dilute acids only. Dilute acids, dilute bases. So now one of the students asked, can gold be dissolved in concentrated? The answer is no. Gold be dissolved with concentrated H2SO4? No. Gold will dissolve with concentrated sulfuric acid? Yeah, HCl and H2? No. Okay, student? It's only aqua regia which the gold can be dissolved, neither any dilute acid nor any concentrated acid, student. Okay, so yes, Ponnappa, sir, which is more reactive, concentrated? Concentrated only, that should be, you see, yes, Narendran, you're absolutely right. I'm giving that as an exception, okay? Yeah, so student, your Ponnappa, so once we are diluting the things, diluting itself it is not so strong, first of all. So there only you should say. Okay, which is more reactive? Obviously, concentrated is more reactive than dilute, but we are not using for your particular thing. Again, so here is there any exception here? Yes, student. Selenic acid is again an exception. Okay, a rare exception among single. You see, aqua regia is a mixture of two things, HCl and HNO3, I guess. Okay, in a ratio of 3:1. In a ratio of 3:1.
Can you go to the previous page, sir? I want to write AgNO3 plus NaCl.
Yeah, I'm going there. Tanushri. Okay, Tanushri. Okay. So again, there is an exception, selenic acid, but don't concentrate here. This is in your higher classes. You will come to know. Right now, you understand that only aqua regia is
Sir,
helping
can I
us to
just send this
resolve.
in the group?
This one only, student. So student, I am just missing the sequences. If you want, I'll send right now because again, I'll just forget the things.
Okay, sir.
Because some students are asking me individual doubts, so I'm clearing individual doubts regularly. So I'm missing the things nowadays. So photos and videos.
So basically, like concentrated H2SO4 won't.
No concentrated acid is also dissolving gold, student. Pictures, screenshots. Yeah, so I have sent you in the group. Okay. Okay, so what you want to take through Devansh? AgNO3. Where is the student? Where did I take that equation? This one. Okay. AgNO3 plus Cu. Okay, so you all understood, right? So every combination reaction is a redox reaction. The answer is no. If at all, whenever I am mixing compound plus compound, it is not a redox reaction. Okay, but it may become that particular like CaO plus CO2, CaCO3. It's a combination reaction, but not redox reaction. Why, sir? It is a compound. Compound plus compound is not a redox reaction. Okay, so I think I have cleared your doubts, students. Let us go to today's session. Okay, let us go to the today's session. So today, so I'm today's session only. Okay, so today's session, student, we need to complete some anti-rusting techniques and rancidity. Okay, so student, you have seen yesterday rusting.
Go
Iron
to the
plus
previous steps.
oxygen
I want
plus
to write
steel.
AgNO3 plus NaCl gives.
Student, how much will you take? Please write soon. And it is already given in your book. There's no requirement to write. Okay? Okay. Okay, so student, so yes, some questions on the rusting. Yesterday we have finished rusting, right? Corrosion of iron is commonly known as rusting. Corrosion of iron occurs in presence of water and air. Tanushri, Ponnappa. Students are getting confused with the A and B option. Many students gave B as an option. And some of the students gave C as A as an option. Think, student, think. Okay, Mega. Okay, very good. Karthik. Okay. Okay, so now again you are changing the options. So okay, so you see, student, obviously A. Why there is no there is complete relation, right? Corrosion of iron is nothing but Fe plus O2 plus H2O. This is nothing but corrosion or rusting of iron, which is nothing but Fe2O3 dot H2O, water of crystallization. Okay, so corrosion of iron occurs in presence of oxygen and water. So same equation I'm using for option A and R. So why they are not related? They are absolutely related. Both A and R are true. R is the correct explanation of A. Okay. Yeah, if at all I say corrosion of copper, then you would have said, sir, there is no relation. Okay. Yeah. So yeah, students. So if there is an iron bridge at 3 different places, assume this is Goa, Bengal, and
Sir,
Delhi.
what is the answer?
Answer is A beta. Both A and R are true, and R is the correct expression of A. Okay, so give me the answer. Where does this iron bridge corrode less or rust less? I'm asking rust less. Less rusting happens where? Yes, Rujuta, that was wrong answer previously. Okay, Ayana, wrong answer. Narendran, yes. Jahnavi, yes. Maya, yes. Harshini, yes. Okay, very good. Okay. Rust less, Punnappa, rust less beta, less. Mega right answer. Shrugal, I asked only less beta. I'm not asking priority. Yes, Tanushri, right answer. Narendran, very good. Okay, Shayan, right answer. Okay, student. Obviously, it's Delhi. Why? Because both the other places you can see they are just beside some sea. Salinity. First of all, they are beside sea. So humidity will be more. Okay, so humidity will be more, students. So obviously, we should say Delhi is the where the rusting will happen less, student. Yeah, yes. Who is this? Let me see. Yes, Rugal.
Sir, like in Delhi also the air has like some moisture and all those pollutant, it can corrode the end
Yeah,
faster
so
than.
but whenever I'm saying rusting beta, Fp plus O2 plus XH2 only. You should only think about
Sir,
oxygen
but
and
it can
moisture.
also corrode with other things also.
Right. So right now we are in the rusting of topic. So what is equation saying? You can
Oh,
see,
okay.
okay, only equation. You look at the only equation, beta.
Yes,
Okay,
sir, I
so
got
student,
confused.
yeah. In Delhi, we have this particular combination is less student. In Goa and Bengal, obviously there is a high amount of salinity. You see salinity, saltish is there, moisture is more. Okay, so yes. Again, if an iron bridge is there, so in which season does it corrode? Yeah, give me the priority. This one, 1, 2, 3. More to less. More to less, beta. More to less. Which season it will be more corrosive and which season it will be less corrosive? Okay, Harshini, wrong. Google, I don't know. Please give the order now. No, wrong. Shayan. Narendran also wrong. Yes, I think Shrugal is right.
So can you see my answer?
Your answer, no student. Yeah, right now I received. Yes, right. No, wrong answer, Jahnavi. Megha is right. Very good. Varnappa, no. Maya, no. Shayan, yes, Shayan is right. Karthik is again wrong. Very good, Rujuta. Ayana, wrong. Yes, Tanushri is right. Rujuta, are you there, student? Narendran, right?
Yes, sir, I'm having a power cut, so I
Okay,
couldn't hear
okay,
your question.
okay, okay. Okay, so yeah, Rujuta wrong. So student, so Iron Bridge, it is, you see, rainy is the first. Why, sir? Why rainy? Because lot of water, already oxygen will be in the atmosphere. Always the Iron Bridge will be full of water, student, full of moisture. So this combination will more. So in the rainy season, it will corrode more. Second is summer, student. Why, sir, summer? You have seen in the modern periodic table. So you see, whenever I am increasing the heat, you see this fellow aluminium will not react with water, but it will react with steam. Steam, gas, right? Water in gas, water in the gaseous state. That means whenever temperature is increasing, this is more reactive. Like you see, iron will not react with cold water. Iron will not react with hot water. Iron will react with steam. That means whenever temperature is increasing, the metals are more prone to the reactiveness. Pardon me. Okay, whenever temperature is increasing, the metals are increasing their reactivity. So you can just say, sir, in summer, definitely iron bridge, the temperature will be somewhat more. Iron bridge will be corrosioness will be more, followed by winter. So in winter also, you can see, student, you will not find more humidity at all. Winter, you just assume something in Delhi, Hyderabad. Hyderabad is somewhat okay, but you can also see the places like Goa where there is full of water. In winter, you will not feel more humidity. Okay, so this gives monsoon rainy season full of corrosion, followed by summer, followed by winter. Winter is the lowest risk. Okay, and also you can give the same explanation, sir. Winter means temperature will be less. So when temperature is decreasing, the reactivity decreases. So they will be not more reactive. Okay, so in that way you can give that particular answer. Okay, so the answer is rainy, more corrosive, followed by summer, followed by winter. More to less beta, more corrosion to less corrosion. Okay, Rujita, understood beta?
Yes, sir.
Okay, yeah. Ship suffers a lot of damage from rusting in spite of being painted because, yeah, in spite of painting, ship still suffers a lot of damage. Rusting. Damage is nothing but rusting. The reason? Yes, right answer. Okay. So yes, Megha. So what? So your answer is right. So what does salt do?
Sir, salts like MgCl absorbs water, right?
Okay. So you want to say, sir, the salt will absorb more moisture to the surface,
Yes,
right?
sir.
Absolutely right. Okay, student. The saltiness or salinity of the water will increase conductivity. You see, water may not be conducting, but if you add some salt and you see that that particular water will be used as a conducting water in batteries, not in batteries, sorry, in batteries it's distilled water. Like you see some of the our homes when you see the ground wire, it is just joined at one of the pit around the home. In that pit we are mixing some salts, in that pit we are mixing some salts so that it will be more conductive and more voltage will be grounded. Okay, so salt will increase the conductivity. Okay. Yeah, so now the topic comes how to prevent rusting. So yesterday we have learned rusting. So how to prevent it? Okay. So student, there are 3 to 4 techniques in your CBSE. We have many in the real world. 3 to 4 in CBSE. Let us go. Alloying is the first trick, student. Alloying. What is alloying? Mixing the things. Like you see, we will use particular iron pipes underground on many of the places we use the iron thing. Okay, now, if you want to make iron thing is why we use iron, because it is strong enough. It is strong enough, so we are using it. But it is prone to corrosion. How to avoid it? Mix iron with some other thing, something like carbon, manganese. Like you see, our utensils, they are all stainless steel. Why? So we want very strong things. So I want to use iron, but it will be corrosive. So what will I add? I'll add carbon. I'll add nickel. I'll add chromium. What is this combination? Stainless steel. Okay, so what? Stainless steel, right? Yeah. So what did help me? So iron I use, so strongness is preserved. These all things, carbon I use a non-metal, nickel and chromium I use, these are definitely low corrosive, low corrosive. So when I am mixing the things, homogeneous mixing we call it here. So we can say that they are
The previous
definitely
page, sir, what is the answer?
copper, yeah. What the answer is seawater contains many salts. Seawater contains many. Okay, so in that way we can just say mixing metals and non-metals will help rust, will avoid rusting. This is first scenario. Is there any other technique? Yeah, so you see copper, pure copper is again, it may corrode. There is a chance to corrosion. But if you mix with zinc or copper with tin, which we use as a bronze medal, brass item, we want to preserve it for more days. Okay, we want to preserve it for our memories. So definitely, so the alloys are helping not to get rusted easily. Okay, students? Yeah. So the second technique is pre-painting. What does painting do? So whatever iron is inside, it is separating oxygen, water with iron. So the surface is barriered. Okay. This painting is developing a barrier between oxygen, moisture, and iron. In that way, iron is not getting direct contact with the oxygen and moisture. In that way, again, so it's a temporary again. So this paint will react now. After some days, this paint will be lost. Again, the rusting will happen. You need to do it frequently to avoid rusting. Okay, painting is another technique. Okay, yeah, the third technique is sacrificial protection. Sacrificial protection, what does that do? If I am using some iron pipe or iron metal which is very strong and I want this particular metal, but I want to avoid corrosion, I will bring another metal, something like zinc, and I'll paint this iron with zinc. What is the trick known as, friend? Galvanization. You see, this tool is an iron tool. I'm using it regularly because it's very hard and I want that tool, but it is very prone to corrosion. What will I do? I'll just heat some molten zinc and immerse this fellow. Now you can see this entire iron thing will be coated with zinc. Now, whenever oxygen and moisture want to attack iron, it should first attack zinc. Now, zinc will get corroded, or you can just say zinc will get oxidized, zinc oxide. Definitely zinc will be destroying. So that is the reason sacrificing. Zinc is sacrificing itself for the iron, student. Zinc is sacrificing itself for the iron. Like a fuse. Yeah, very good, Punapa. Like a fuse. Absolutely right. Okay, like a fuse. So in current electricity also, fuse will definitely burn. But in spite of burning our TVs, fridge, which are very costly, fuse is hardly some 2 rupees or 3 rupees. So we can just have it. Okay. Similarly, zinc is somewhat cheaper and zinc oxide. There is one more thing, student. Yeah, I'll come to that point. So one of the student has said, sir, in my book, so if zinc is also removed, the paint, I have galvanized it and I have removed this particular zinc, still my iron will be non-corrosive. So that will not happen. I'll come to that point. What does he mean over there? Okay. So right now, what did I say? Galvanization is another trick where one of the metal will be sacrificing itself. Okay. Why, sir? Why like that? Why? Because you see, iron. So where is that? Yeah, you see, student, iron is here, zinc is here. If oxygen comes, obviously zinc is more reactive than iron. So that's the reason zinc will go and become zinc oxide and iron will be left alone. So zinc is getting sacrificed and but preserving iron. Okay, it's only a reactivity, student, due to reactivity only. Okay, yeah, one more thing. So now the question comes, sir, why only zinc? You see, aluminum is also more reactive than iron. Why can't you use? Obviously, you can use aluminum also as a sacrificial metal. Can you use magnesium? Yes, you can use magnesium also as sacrificial metal to preserve iron. You can use any of them, student, any of them. Okay. Sugar, can you use calcium, potassium? Sorry, potassium, sodium, and calcium also to
Sir, you can't use that because they're so very reactive. They're
yes, very good. So, okay,
reactive.
student, we can't use them. They're very reactive. Okay, you paint it today, by tomorrow it will be gone. So they are way. So we should not waste also, right? So definitely these three metals are sacrificing. Okay, to preserve iron. If at all you want to take to preserve iron, which metals are going to sacrifice? You can choose from this list: magnesium, aluminium, and zinc. They're very reactive. Yes, my right answer. Okay, so like that. So student, now the question comes, sir, why aluminum? You see, aluminum, magnesium has one more property. What is the property? Whenever aluminum, you are just using preserving aluminum. You see, inside is iron, you have painted aluminum. Here also rusting happens. Here also aluminum will get oxygen. But aluminum, the corrosion outside layer is very strong. Once Al2O3 is formed, the outside layer of aluminum is very strong. Now, whenever oxygen and water wants to penetrate inside, that will not allow. Outside coating which has been oxidized, that is strong enough, that will not let more aluminum or the iron inside to be corroded. It is becoming very strong. So we call it as a passivation. Passivation, opposite of rusting. Rusting means entire metal it is eating, inside also it is eating. But this particular aluminum is a passivation. Only the top layer will be eaten away or the corroded away, but not the inside layer. Okay, okay. Non-porous, very good. Right word, non-porous. Why no use tin, sir? Because tin coating prevents itself from acting, prevent iron, right? We should also see durability. If you coat tin, the tin may not hold that particular iron so strong enough. Okay, we should see many things. So right now we are concentrating only on rusting. When you go for the overall use, okay, if I paint with tin, if I'm using that hammer, so the tin may go away. So that time again we will not be using the tin. Okay, okay, okay. Yeah, the fourth is nothing but cathodic protection, student. Cathodic protection. You see, the particular whenever we see our usable items which are submerged, especially the ships which are submerged in water, they're prone to very corrosive environment, student. Okay, so there what technique we will use? We will not use painting, we will not use that particular alloying, we will not use that particular sacrificial. We use cathodic protection. Okay, cathodic protection, student. What we you see? There is a pipe, underground pipe. Okay, so this underground pipe, obviously some moisture will be there, some oxygen, some layers of oxygen will be there. Definitely corrosion will happen. So what we do here? So here we are using some cathodic protection. Okay, we'll not go very deep into it. It's a very long, big subject. Okay, so what is this trick is nothing but I'm just using some zinc or something like sacrificial metal only. Something like zinc I am using and I'm connecting it with a wire or just kept aside, just kept beside or connecting with wire. Now, when oxygen and water O2 plus H2O want to attack this fellow, it will be seeing that there is another metal like zinc. Now again the combination goes. So now Fe is there and zinc is there. Whom I should attack in both of them? Again it will be choosing zinc. Again they why sir? Because zinc is more reactive here. Okay. So whoever is more reactive, that is nothing but anode. Anode. So in this terminology, zinc is anode. And whom I am protecting now? Iron is going protected. So that is what we say cathodic protection. Okay. So here in this scenario, the one metal which is sacrificing here, they are calling it as anode. And once I am correcting anode, so this combination is destroying this anode. And who is protected? Cathode is protected. Who is cathode here? Iron is cathode. So this is known as cathodic protection. Okay, this is a very big subject, student. So I have given it an easy way. Okay. So and but this particular zinc should be very nearby, or at least it should be connected with a wire like this. Only then this cathodic protection will work. Understood, Narendran?
Yes, sir.
Yeah. So student, yes, four tricks you need to know. Four things you need to know. Okay. Alloying, painting, sacrifice this particular galvanization, and the cathodic protection. Okay. I have framed some notes on cathodic protection, but I don't think you require this much concept. Okay. That's the reason I gave it in very easy. Okay. Yeah. Which of the following metals can be used to prevent rusting? More than one correct. Everybody should answer. Aparna, Avdan, Ayana, Devansh, Harshini, Janavi, Karthik, Maya, Megha, Narendran, Ponnappa, Rujuta, Shayan, Shrugal, Tanish, Tanushri. Everybody should answer. 16 answer I should get from there. And one answer in my WhatsApp. Shrugal, wrong answer. Megha, right answer. Narendran, right answer. Tanushri, only half answer right. Shrugal and Tanushri. Tanish, I'm saying more than one correct beta. Please choose multiple options. Ponnappa, half answer right. Maya, right answer. Harshini, right answer. Jahnavi, very good, right answer. Rujita, half answer right. Karthik, no, only 25% right. All of the above, again wrong, Tanushri. Chayan, half answer right. Okay, so students, we have seen no Pannappa, half answer right. Aparna, half answer right. So rusting is a word, fancy word used for iron only. So just now we have seen. So to preserve iron, I can use these three beta: zinc, aluminium, magnesium. All the three I can use. Okay, zinc is not there. Zinc is there. Aluminium, magnesium. All the three I can use. I can also use calcium, but this top one is very reactive to oxygen. So in hardly 1 hour or 1 day, they all will just get oxidized. So that's the reason I'm not conceptually this thing also be used. But so there is no so it is not economic. Economically, it is not possible. In 1 day, it will destroy it. It will get destroyed. So A, B, C is the right answer, student. A, B, C. A, B, C is the right answer. Understood, Tanushri?
Yes,
Tanushri.
sir.
What is the answer, sir?
Answer A, B, C, beta. A, B, C. A, B, C. Which of the following is an alloy of iron? Okay, so no problem. Steel, leave it now. No deposit steel used to prevent rusting. Yeah. Which metal is deposited on steel beams used in bridges to prevent them from rusting? Metal is deposited on steel beams, beta. Steel beams. Jahnavi, right answer. Strugal, wrong answer. Rujita, right answer. Harshini, wrong answer. Maya, wrong answer. Harshini, Harshini, right answer. Chayan, wrong answer. Ponnappa, right answer. Tanish, very good, right answer. Narendran, wrong answer. You're missing the keywords. Mega, right answer. Students, so see, concentrate. Yes, Strugal, right answer. Look at the keyword. He's asking deposit. Is he asking mixing? If mixing, then you would have said, sir, this particular steel will be made up of chromium and nickel. So it will be alloying. But did he say mixing? Depositing. So where is depositing word used for just now in our techniques? So we have used the depositing word for only this beta. Okay, galvanization. Okay, the top layer will be zinc will be deposited on the top layer. Okay, so the answer should be only zinc. The answer should be only zinc. Yes, Shayan, right answer. Narendran, right answer. You see the answer which you know, still you'll getting confused. That is because you should go for the so okay, let me use so where is it? We should go for the technical words like deposited. Okay, deposited. Yes.
What is the answer?
Zinc. Zinc is the answer, not chromium. Why not?
Then
Yes.
what is
So
the answer?
student.
Go to the previous.
Yeah, so Shrugal, I said the chromium and nickel, you can't deposit it. You can mix with iron. Fe plus Cr plus Ni is alloy. But he said deposit. Deposit means the topmost layer of iron should get deposited. Okay, so that is zinc beta. Come on, everybody should do. Yes, is Karthik there? Karthik, are you there, beta? Not there. Narendran, very good. I think you are right, Narendran. Yes, Harshini, right answer. Meghu, check your answer, bachchi. Ponnappa, Ayana, Shayan, Aparna, Tanish, Rujuta, Audan. Please switch on your cameras. I'll remove you from the sessions. Megha, right answer. Tanushri, no. Tanish, no. Easy answer, still making mistakes. Maya, yes, very good. Rujuta, no. Jahnavi, no. Shrugal, no. Friend, why are you giving all A? Let me see. Naina. Stainless steel rusts more quickly as it contains carbon and absolutely not. We are using stainless steel so that it will not rust. So false. Salt water slows the process. Just now I have said salty water increases the conductivity and rusting. False. Depositing a layer of iron on zinc is called galvanization. Again false. आयरन के ऊपर जिंक डिपॉजिट होना चाहिए बट व्हाट डिड ही सेड दैट जिंक के ऊपर आयरन डिपॉजिट हो रहा है दिस इज रॉन्ग बेटा यू सी you need to deposit a layer of zinc on iron so all the three are false so they are not students from veteran tuitions okay yes Ponnappa Shayan right Tanushri no Rujuta yes okay so all the three things are false student okay understood Shrugal now
The screenshots.
yes, Shrugal. Ponnappa understood. Ask me doubts, Ponnappa.
Sir, I gave the answer.
Oh, Ponnappa gave right answer. Very good, Ponnappa. Okay, barrier method. This all we finish. Yeah. Let us come to the particular food student. Rancidity.
Sir, just screenshot.
Devansh, I said that you already took this entire sheet, student. I'm just revising the thing. I am not teaching any new thing new. All my slides are covered, and you are from the very first day. Okay, so give me some time to cover the syllabus, Devansh. Rancidity, student. What is rancidity? So yesterday we have said about the food, right? The food gets some foul smell. What is that? Again, rancidity. Aerial oxidation of food. Just now we have seen metals are getting oxidized. Metals are, you see, this fellow is rusting, this fellow is oxidation. So we are on this Cu plus O2 also. Okay, copper oxide, rusting, corrosion we have seen. So the same thing happens with the food also. That in that food we will not use the word rusting, corrosion. We will use the word rancidity. Rancidity. Food also gets destroyed. Why, sir? How will food get destroyed? Obviously, food means what is the student already microorganisms are there. Once these microorganisms, food is already here. Food is already there. And to get energy, what they require? They only require oxygen. We all have learned in that particular cellular respiration in biology. T6H12O6. Food plus oxygen. What will you? It will give us energy. So every organism requires energy. So it wants food and oxygen. Food is already here, and from the atmosphere, if oxygen gets it, obviously it will get energy, and obviously the microorganism will poop out the wastage, right? Definitely, that is where that particular foul smell all will be coming, student. Okay, ATP plus H2O plus CO2. right? This is what the particular in biology we have read in the cellular respiration. The same thing is happening here. Okay, so fats and oils on the present on the food gets oxidized by the oxygen. So their oxidation products gives unpleasant smell and taste. That is what rancidity definition, which is same in your syllabus also. Then how to avoid rancidity, sir? Shall we use zinc? Shall we use chromium? The answer is no. What we will use? We will use something like preservatives which we can consume it. Okay, what are those? These are antioxidants. You see here, oxidation is happening. Oxidation. We should avoid this oxidation. So we should use antioxidants. Okay, please remember these names: BHA, BHT, butylated hydroxyanisole, butylated hydroxytoluene. Okay, so if you mix this particular thing, you can consume it, but you can consume it. It is not so harmful. Student, again, if you consume in more quantities, again you will be affected with cancer. So in limited quantities, we can consume it, and if you add this, that food will be preserved. Yes, Harshini, why the food will be preserved if you add it?
Sir, the living conditions for the microorganism will not be fulfilled.
Partially, not perfectly. Anybody? Anybody? You can use the same technique. Iron plus zinc. Why iron is not getting corroded or rusted when
So
zinc
it
is added?
prevents the food from getting oxidized because it forms a layer over the food.
No, nothing. That's not the right answer. So I did not say.
This
Sir,
is
oxygen
more
will be going with
Yes.
this.
Yes, obviously. Harshini and Narendran, right. You see, student, this is more reactive. This powder is more reactive than fats and oils on the bread. You see, on the bread, if I mix this, so here, if oxygen want to attack this particular fat, here there is a BHT and BCD powder. So this oxygen will go and attack this fellow. Okay. So it's just as good as reactiveness. BHA and BHT are more reactive than the fats and oils on the food. That is the reason your this thing will be used. Okay, so you see, student, that particular ready-made chapati roti, after getting this fellow getting oxidized completely, again the particular oxygen will attack food. That is the reason after 15 days the food will be destroyed. It is only up to 15 days that particular ready-made chapati will be saved. After 15 days, the particular living organism, that particular oxidation will be happening on BHT. Again, obviously, the next attack will be on the food. Okay. Yeah, another trick is definitely rancidity can be prevented by packing fat and oil containing food with nitrogen gas. Okay, nitrogen gas. You see this particular Lay's chips. We are all using the nitrogen gas, student. Okay, why Ponappa? Why only nitrogen gas? You see, in the modern periodic table from the very first day, we have learned about the noble gases which are least reactive. Why not this? Why we are choosing nitrogen gas?
So, like if we use other gases, like if we use helium and all, it will not be that cheap also, and
Very
it have
good.
other properties.
Okay, very good. Okay, so student, yes, abundant, very good. Okay, so student, nitrogen is readily available. You see, our atmosphere is 71% nitrogen. Okay, first of all, easily available and it is least reactive. Okay, yeah. Okay, so these two are the things which makes nitrogen, and you can see from atmosphere if nitrogen is available, the manufacturing cost will also be cheaper. Inert gases, you need to just use some particular large apparatus to particular collect them, but this nitrogen is easy available. So every food production company will just make this particular nitrogen nitrogen plant. It can collect directly from atmosphere. Okay, so the cheap, it's very cheap. Okay, yes, definitely you refrigerate the things, and again revise why refrigeration is just helping this thing. As we just now we have seen, whenever something like coal or temperature is less, the reaction will be less. The same thing here. Okay, whenever you keep the things in the fridge, the temperature is less, so rate of reaction will be less. Airtight container is one thing which Rujuta was saying. Okay, sir, I'll remove all that particular oxygen available. So it's an airtight container. Okay, stop the flow. Okay. So Konappa is asking some doubt. Sir, if oil is the problem of acid, then why in people they will not only oil, student, there are something else over there. Okay, so I have discussed in acids, bases, and salts about that particular. So only oil will not help it. That So some salt is also being added. You see that pickle, if you add low salt, what will happen? Your pickle will be destroyed. You need to add more salt that will make a layer on it. Okay. The main cause of rancidity in foods is, yes, Ponnappa right, Megha right, Narendran right, Harshini right. Come on, Shayan, Rujuta, Maya, Tanushri, Jahnavi right, Rujuta right, Shayan, Shayan, very good. Maya, Maya, no beta.
So, but technically, without bacteria, the actual definition won't work either, right?
Yeah, but rancidity definition, we spoke about the oxidation.
Okay, sir.
Okay. Sugar, no. Okay. So, student, even though you all are right, but when I discuss rancidity, I just spoke about oxidation of fats and oil. So, please go with your textbook definitions meaning. Definitely, if bacteria should be there. Okay. And it will be there. So, it's D is the right answer. Oxidation of fats and oils in food. The main concept of rancidity in foods is oxidation of the fats and oil in food. A student wrote 3 statements about rancidity. When fats and oils are reduced, they become rancid. Chips manufacturers usually flush chips back with oxygen to prevent rancidity. Rancidity is prevented by adding substances called antioxidants to food. Choose the correct statement. Narendran, you're right. Harshini, right. Rujita, right. Yes, Maya, right. Shayan, right. Jahnavi, right. Mega, right. Now you all are veteran tuition kids. Google, no, you're still not. 3 statement about rancidity. Choose a correct statement, beta. Correct statement is asking. When fats and oils are not reduced, they are oxidized. You see how technical words are there. Fats and oils are oxidized. Then only they become rancid. Okay. Chip manufacturer usually flush chip with nitrogen. I want to avoid oxygen. How can I fill with oxygen? Nitrogen. Okay. Rancidity is prevented and substance called antioxidant. Yes, rancidity means oxidation. If I add antioxidant, I can preserve the food. So only 3 is the right option, student. 3 only. Okay. Yes, yes, Tanish. One more student. Who is that? Ayana is there. Aparna, where are you? You are not giving answers, Aparna. BHT, BHA. Okay. Leave it. Okay.
And the screenshot, sir.
No screenshot, business student. We finish this session. Okay. Oh, so you see, these are some questions which are repeated from this topic. What is galvanization? Name 3 metals which can be used for sacrificial protection. Same, just now we discussed magnesium, aluminium, and zinc. What is the full form of BHT? We have just discussed it. Okay, toluene and anisole, that one. Why? What is the use of nitrogen and gas in rancidity? Obviously, it will avoid the oxidation of fats and oils because it is filled with nitrogen gas. Okay. So that was about the food, student. Yeah. Have you seen or done toilet cleaning? You see, student, please remember Harpic is having high HCl acid. So many questions he is framing on Harpic. Harpic. Okay, but don't say, sir, Harpic you have not taught us. Harpic has some acid, HCl acid. Okay. With that, give this answer. Which gas is produced when magnesium reacts with Harpic? Magnesium reacts with Harpic. Which gas is produced? Thank you. Tanish, right answer. Shrugal, right answer. Mega, right answer. Maya, right answer. Rujita, right answer. Janavi, right answer. Jatayan, wrong answer. Harshini, right answer. Narendran, right answer. Very good, student. Shayan, right answer, beta. Aparna, some answer. Aparna, wrong answer, बच्ची 1855. Why methane? Methane कहाँ से आ गए बच्ची? One आपका right answer. You see, student, magnesium plus HCl, metal with acid. You'll get salt plus hydrogen gas. So option should be A. Okay. Harpic means blindly take HCl. Harpic means blindly take HCl. Understood, Aparna? Why methane came? Where does this methane came from?
Yes,
In
I understand.
in reaction of magnesium with Harpic, is reaction of magnesium with Harpic a redox reaction? Magnesium plus Harpic, क्या ये redox reaction है? Again, magnesium plus HCl, is it a redox reaction? Very good, Ponnappa. Maya, right answer. Shayan, right answer. Harshini, very good. So I have cleared one student's doubt, you see. That will help you here. I just said redox reaction means. Jahnavi, no. Narendran, right. Rujuta, no. Okay, so student, you see, element plus compound. Element plus compound is a redox reaction. I have shown you today when I cleared some doubt, right? Where is it? I have sent you in the group also, student. Yeah, you see, element plus compound is a redox reaction. Element plus compound. You can use same technique. Suppose you forgot it. Suppose you forgot, no sir, I don't remember such tricks. You go with the basics. So what is the basics? So let me just go with the final formula and give you what is the answer. Yeah, suppose you are saying, no, I don't know whether it is redox, I forgot the thing. You just write the reaction and go ahead. Mg plus HCl, metal plus acid, salt plus hydrogen gas, plus little heat will also be produced. Huh? Okay, so I'll write heat. Now you see, student, sir, magnesium oxidation state. Every element oxidation state. Yesterday, what did I say? Every element here, oxidation state will be 0. So magnesium is an element 0. But when you look at here, Cl का -1 है, Mg का +2 है. 0 to +2. Oxidation state has changed. What is this? Loss of electron. Oxidize. Okay. And what else, student? That's all. Chlorine -1. Hydrogen. I don't know whether how to explain reduction. Where is reduction happening here? So Cl is -1. Hydrogen. Yeah, hydrogen is 0. Here hydrogen is +1. You see, student, +1 to 0. What happened? Okay. Gain of electrons. Reduction. That's the reason, student. Reduction and oxidation both are happening here. It's a redox reaction. Yes. Your answer should be yes. Okay, this is a basic way of explaining. Okay, if you remember the trick, the element and compound redox reaction hoga, write it. If you don't remember, at least you saw this. Today's recording. Why, Shruga? You liked it very much? Asking recording?
No, sir, this is like very important.
Okay.
This is the where I didn't understand.
Okay. Okay, so either use the trick or you just draw the oxidation state. Harshini, understood the oxidation state, beta?
Yes.
Okay, very good. Yeah, just now I said, student, magnesium plus Harpic, magnesium plus HCl, a little heat will be produced exothermic. I think in the regular, when you start using Harpic in the bathroom also, the temperature of the bathroom will be increasing. Okay, because it's an exothermic reaction. Okay, yes, exothermic. Okay, yeah, student. Now this all you can, I think you can surely do it. Whenever I'm asking a Harpic, you take this aluminum plus HCl. Okay, I think you can do. Yeah, so this one, student. Why do aluminum foil pieces not react with Harpic?
Sir, what is the answer? Which type of reaction is the reaction?
Redox reaction. Redox reaction. No. Can acid react with acid? Harshini, very good. Tanish, 1900. No, student Tanish. Mega, right answer. Ponnappa, no. Shayan, right answer. Maya, right answer. Tanish, right answer. Sugal, right answer. Okay, so student, what is saying? Aluminium foil plus Harpic, he said, but HCl. So just now I said metal with acid salt AlCl3 plus hydrogen gas. But here that fellow has taken aluminum foil. It's a foil. So look at the aluminum foil, how it looks like. It looks like this beta. It looks like this. What happened is it is in the open environment. So all the oxygen, all the topmost layer of oxygen, it gets oxidized. Topmost layer of aluminum get oxidized. So basically on the surface there is Al2O3. Al2O3 will not react with HCl, which is very dilute. Very dilute. This is okay. Very dilute. Not concentrated. The Harpic we are using at home is very dilute. So the reaction will not happen. Even though I asked you aluminum plus HCl, but I asked you the aluminum foil, you should take Al2O3 plus HCl, which is again non-reactive. Why? Because the oxide layer is very strong. I have said the passivation. I said that aluminum will also get corroded, but only the topmost layer will get corroded. It will not allow the further corrosion. Why? Because this topmost layer will be very strong. Understood, Ponnappa? Acha, Ponnappa gave the right answer, I guess. Ponnappa, understood, beta?
Yes, sir, I understood. I didn't give the right answer.
So you didn't give the right answer. Okay. Very polite guy. Thank you.
Sir, what
Naren,
is the answer? Do not react with
which gas is not this one? Aluminum foil. Yeah. So because of oxide layer is the answer. Why do aluminum foil not react with Harpic? Because of oxide layer. Okay. Rujita, are you following, student? Rujita, following, beta?
Yes, sir.
Okay. Yeah, so let's not go into more number of questions. Yeah, so student, you see what is this? NaHCO3, what is this? Baking soda, sodium bicarbonate, baking soda plus Harpic. What will happen? Obviously, sir, it's a base. It's an acid. Base plus acid, salt should come. But as it is CO3 is there, in spite of H2, you will get CO2 gas. It's a base here, student. It's pure base, not metal. Metal carbonate it is. Metal carbonate. So whenever somebody asks, so if I mix baking soda and Harpic, what will happen? You should write this. Okay, baking soda, NaCO3, Harpic, HCl. Okay, obviously CO2 gas will be coming here. Okay, yeah, that's with the story of rusting, anti-rusting, and rancidity. Okay, yes, Harshini and Vega right on. Okay, so now the story of this particular, what is this, student? The balancing we'll come to know. Okay, so student, even though you see H2 plus O2 equal to H2 is absolutely right, but it is not balanced. Okay, there are some quotients are missing. And why do we require balancing? Yes, obviously we require balancing to explain what is that? A law of conservation of mass, right? Yeah, law of conservation of mass is required. We need to show that left hand side, right hand side, the masses are same. How will you show that? How will you show the shirt? You see, the same reaction I took, H2 plus O2 equal to H2O, it's not balanced. If you weigh left hand side, right hand side, it will not be balanced. The reactants and products should be balanced. Now, whenever I'm speaking about balancing, I'm speaking about the masses. And in the periodic table, where are the masses written? Look at here very carefully. In some of the questions, he's giving this number 10, 12. So these are the mass numbers. Okay. Till now, we are discussing oxygen means 8. Only the number of protons or number of electrons. Whenever I say magnesium, you are saying 12, which is nothing but number of protons and number of electrons. But right now I'm saying mass number, which is written in the down beta. Down. What is mass number? You can just take it as a weight, student. Atomic mass unit. I'll not go very deep. For some of the students who want to know, mass number is nothing but number of protons plus neutrons. Number of protons plus neutrons. Right now you assume it is a weight. Okay, in order to follow law
Sir,
of
can we
conservation
just
of-
take oxygen as 16 instead of 15.9?
Yes, you will be taking the same thing, student. Okay, we will not go into so much decimals. We'll be taking same. Okay, so student, so now let me measure the weight. Okay, where is, so I have hydrogen and oxygen. Look at here, hydrogen and oxygen. What are the weights of it? So you can clearly see hydrogen has one atomic mass unit. You can also say one unit. And where is oxygen? Oxygen kahan hai bachcha? Oxygen is here. Oxygen is 16 units beta. 15.99. Let us take 16 units. So you got the weight of hydrogen and oxygen. Now let us use that weight. Okay. So how many hydrogen? Obviously, sir, H2, 2 hydrogens, 2 units. Oxygen, 1 oxygen is 16 units. So 2 oxygen matlab 32 units. So how much is left side weight, student? 34 units. Let me go with the right side. Hydrogen, 2 units, 2 hydrogens. Oxygen, 16 units. 18 units only. Is it balanced? No, the mass is not balanced. So what should I do? So I'll say that, sir, please multiply by 2. So that 18 into 2 will be 30. How much, student? 16, 17, 18.
So that's 36 and this is 34.
34, right? 1 second. H2 plus, I think 2H2 will come, right? 2H2 will come, okay? So obviously, student, here 18 and 34, it is still not balanced. So what you should do? You should again multiply with this 2. So this will be 2, 34 plus 2, 36 here, 18 into 2, 36 here. Like that, you need to balance. But is it possible always to use this balance bridge? No. That's the reason we are having some 3 methods, student. What are those methods? Those methods are table method, hit and trial method, ABCD method. Okay. So to balance any chemical reaction, we'll be using these 3 methods. I'll say table method, but it's your wish. So some students are very comfortable in this method, but I am comfortable in this ABCD method and hit and trial method also. Okay, that's up to you. I'll explain these 3 methods. Okay, student. Let us go with the table method. Let us start with the table method. Okay, the same equation. Let us take, student. Okay, so this is what the equation is. I want to balance. What to do? Make a table. I took a table and write the number of atoms in each side. So elements, क्या क्या elements है बेटा? Hydrogen है, oxygen है. How many left hand side? 2 hydrogen, 2 oxygen. Right hand side कैसा है बच्चा? So number of atoms in elements you take. Hydrogen or 2, oxygen is 1. Did you all understand? Table method means you need to write table and you need to write which elements are there in my chemical reaction or chemical equation, and you choose left hand side, right hand. Left hand side hydrogen 2, oxygen 2. Right hand and hydrogen 2, oxygen 1. Now are they balanced? No, they are not balanced. So what should I do? I should multiply this 2. So now 1 into 2 equal to 2. But if I multiply with this 2, this oxygen on right side is again with hydrogen. Hydrogen will also get multiplied by 2, which is 4. Okay. Now you see, student, this fellow is balanced, but this fellow is not balanced. If I multiply 2 for making oxygen balance, but again hydrogen is not balanced. Left side it is, okay. So left side it is only 2, right side it is 4. What should I do? I should also multiply left side by 2 like this. Okay. So now you can see this balance table method. Okay. Let me take one more example. Let's clear your doubts. Okay. So elements, what are the elements are there? I am able to see lead, nitrogen and oxygen. Left hand side, how many lead are there? 1. How many nitrogen? Here 1 and outside 2. 1 into 2, 2 beta. You should not say 1. It is 2 is for both of them. 2. Oxygen 3 and 2. 3 2s are 6. RHS right hand side, lead कितना है? 1. नाइट्रोजन कितना है? 1. ऑक्सीजन कितना है? 2 2 4 5. Okay, now again I'm able to see it is not balanced. Okay, right now it is not. What should I do to make balance? So you see here 2, here 1. Can I multiply by 2? Obviously you can multiply by 2, but whenever you are multiplying by 2 with the nitrogen is here. If you are multiplying, it is again disturbing oxygen. Now let me write how many oxygen is there. 2 2s are 4, 5 6 7. So 7 I wrote. Now this is balanced, this is balanced. Again this fellow is not balanced. Okay, what should I do to make it balanced? You can again multiply with minimum, you can multiply with 2 beta. You want 7, but you have no option. If you multiply with 1, it is again 6. Minimum you need to multiply by 2 only. 6 2s are 12. But will that happen? Will the remaining will not change? You see, if I multiply with 2, everything got changed. Lead, again you should change to 2. Oxygen, that is nitrogen, which was 1, which was 2, 1 into 2, 2. Again it is multiplied by 2, 2 2s are 4. Like that, student, everything gets changed. Student. So that is the reason table method, if you are comfortable, you can use that. But the first choice should be hit and trial method, followed by ABCD method. Okay. So let us go for hit and trial method next. What is hit and trial method? Na plus Cl2 is NaCl. Clearly, I can see, sir, Na is balanced. Here, 2 chlorine, 2. Array, sir, it has disturbed sodium, 2 sodium, 2. I'll multiply with 2. Finish. This is the hit and trial method. What did I do? I started the balancing by easiest elements. Keep doing until the equation is balanced. You can try fractions also. Okay. Let me take one more example. Okay. So, student, this is important. Hit and trial is important. Okay. Okay. Yes, Harshini, help me, student. KClO3, KClO2. What should I multiply here?
So like right now,
Right now I want to balance it by hit and trial method.
so
What
should
will
we
you
start
balance?
with O2 then?
No, I said start with the easiest one.
Yes, sir, but KCl is already balanced, right?
Yeah,
At
so
the
that
moment.
you say that word. So the
Okay, so
easiest.
nothing one.
Okay, yeah, the easiest one is already done. Let's go for the complicated one. Here 3 oxygen beta, here 2 oxygen. How can I make it 3?
Sir, multiply with 3 here, so it becomes 6. Then we do 3 there for
Okay.
KClO3.
Okay. Any other thing? Yes, Narendran. Any other way?
So multiply 3 with O2.
So you want to multiply with 3?
Yes,
Okay,
sir.
so again this will be disturbed. So student, I want to just introduce this particular fraction method also. Why you are always going for that? You see, multiply by 3 by 2. What is 3 by 2 into 2? 3. So here also 3 oxygen, here also 3 oxygen. You can do this also. Okay, you can do this also, but this is not the final step. So student, whenever you are feeling complicated, you can do these fractions also. You see, KCl is balanced. Sir, oxygen we have 3, here we have 2. Multiply by 3 by 2. Obviously, you will get 3 oxygen on the right. Now it is balanced, but please don't leave the fraction like this. Okay, so how to avoid fraction? Multiply by 2 on both sides. Sir, I'll multiply by 2 here also, here also. Finish, student. 2 into KClO3, 2 KClO3, 2 into KCl, 2 KCl, 2 into 3 by 2 O2, 3 O2. Balanced. Shrugal, did you understand this way?
Yes, sir. I get the answer.
You get the answer? Okay. Okay. Yes, student. Yes, Ponnappa, same student. Start with the easiest one. So what do you feel easiest one? Yes, Ponnappa. Start with the easiest.
Both. So CO2.
You say me individual element, individual. Is it carbon, hydrogen, oxygen? Where, whom should start with?
Okay. Oxygen.
Oxygen. You see, oxygen is a complicated one. You see, oxygen is here and here. Go with the easiest one. You see, carbon,
This is
only one
carbon.
place. Carbon, okay. You see here, 4 carbon, 4 carbon. Carbon is balanced. Hydrogen, 10 beta. What should I do here? Ponnappa. Hydrogen, there are 10. What
So
should I do?
multiply by 5.
5. Very good, student. You see, carbon is balanced, hydrogen is balanced. Now, oxygen, there are 2. Here, how many? 4 2s are 8 plus 5. 13 are there. So, what should I multiply here? Ponnappa. Right side, oxygen, I have 8 plus 5, 13. I want 13 here. What should I multiply here? To get here 13 oxygen.
13 by 2.
Very good. That's all. Finished. Okay, finished, student. That is what this hit and trial method is. Okay, just start with the easiest one and just continue with the other thing. But please don't leave this thing like this. You need to just make it fraction free. So how to avoid fraction free? Multiply by 2. Multiply by 2. 2 into C4H10 plus 2 into 13 by 2 means 13O2. Here 2 into 4 means 8CO2. Here 2 into 5 means 10H2O. Rujita, understood beta?
Yes, sir.
Okay, so the hit and trial method, use that fraction method, all your doubts will be cleared. Okay, the best method, what I assume is ABCD method for the very tough equation, student. ABCD method is the best method for very tough chemical equations. Okay, chemical reactions. What is ABCD method? Okay, so I'll use this particular template. What is ABCD? Use coefficient ABCD. That means I need to multiply A, B, C, D. If there is another compound, I'll multiply with E beta. ABCD method doesn't mean so I should stop with ABCD. It is A, B, C, D, E, F, G, H, everything. Okay. First, I have used this coefficient. For each element, write the equation for coefficients. What does that mean? He said start with A, B, C, D, and he's asking to write the coefficients. Coefficient means how many elements are there? Nitrogen is there, hydrogen is there, oxygen is there. So in nitrogen, A into 1, nothing is there means 1 beta. A into 1 is A. That's all. Equal to right side. C into 1 is C. It's 1 here. Huh? So in the nitrogen, A equal to C is 1 equation. Okay. Second, hydrogen. 3 into A. 3A. Is there any hydrogen? Nothing. Equal to hydrogen here. 2 into D. 2D. Okay. Oxygen. B into 2. 2B. Equal to C into 1. C plus D into 1. D. Understood? I have done 2 steps. First step I have written A, B, C, D. Second step, for each element I have written the equation. The equation looks like this. Okay. Tanushri, are you following, student? Tanushri, are you
Yes,
there?
sir.
Yes, okay. So it's just an ABCD method, beta. For complicated thing, hit and trial will take so much time, and that particular table method you will be lost in adjusting the things. But this method will give you the quick and right answer. Okay, so this is our third trick, student. Okay, now once I have written, what is the third step, student? I should see that find coefficient that occurs most, means I have seen that A is occurring 1, 2, 2 times I have written. B is occurring only 1. C is occurring 1, 2, 2 times I have written. D is occurring 1, 2. Like that I have written. Now, what is the fourth step? Fourth step is nothing but, third step is nothing but again, keep the most occurring fellow as 1. So here I have seen that A, C, D, they all are occurring most, student. I'll assume A equal to 1. Okay, so please assume let A equal to 1. You can assume anything. Okay, so try to assume 1 so that again the calculations will not be happening. Assume 1. If A equal to 1, C equal to 1. You see, already you got these two ratios. A equal to 1, C equal. If C equal to 1, okay, yeah, if A equal to 1, what is D beta? So 3 into 1 is 3, 2D. What is D? 3 by 2. D is 3 by 2. What is B? 2B equal to C plus D. C kitna hai? 1 plus D kitna hai? 3 by 2. Which is nothing but B equal to 5 by 4, right? 5 by 4. Finish, student. You should just write something like this, okay? 5 by 4. A in place of A 1, in place of B 5 by 4, in place of C 1, in place of D 3 by 2. Okay? Yes, Narendran. Now I want to remove this fraction. What should I multiply left side and right side? I should multiply the same number. What is that number?
So 4.
4. Obviously, 4 you should multiply so that this fraction will get cancelled. So your equation will be 4NH3 plus 5O2 will give you, for right side also, 4NO plus 6H2O. This is the final equation. This is ABCD method. Anybody, any doubt, student? For template is, what is the template? You should assume ABCD. Second, you should write the equation. Third, you see, you can assume anything as 1. Fourth, solve the equation. And fifth, ensure you are freeing all of them with the fraction. Okay. So will you try one question? Try this, student. ABCD method. Please give me the A, B, C, D values. A, B, C, D values. Try, student. Even I'll try and you will also try it. Okay. B, A. Please give ABCD values in the chat box. So you have given. Okay, it was previous answer. Acha, Sugal, you have given it. So very good. Sugal, which way did you do? So Narendra, did you get the answer? Is your
Sir,
confusion
that
clear?
is the
Student?
previous one.
Acha, that was previous one.
Yes,
Narendra,
sir.
confusion cleared. Okay. So at least it is helping some students. Okay, very good. Harshini gave the answer. Final, very good. So give all the answers at one step, student. Okay, yeah, you see Shayan has also given. Yes, Shayan, only 3 answers you give. Yes, right answer, Shayan. And Harshini answers also match. So Harshini, is my values right, student? A 4 by 3, B 1 by 2. So now I have not done finally. I'll just use it. But till here, is it right? Did you use this method or not?
Yes, this method, yes, sir. Yes.
Right, right. So A by 3 plus B is 1 by 2 Cl2. C is 1 by 6 N2 plus D is nothing but 1, right? Next 4 C. I need to avoid this particular 6, this particular fraction. So I multiply by 6 here, 6 here. Okay. So my final answer will be 8 NH3 plus 2 3s are 3 Cl2 gives N2 plus 6 NH4. So 8312 should be the answer. Let me see the 83116 or 8316. Shayan, absolutely right. Maya, absolutely right. Jahnavi, can you show in table method? So student table method, lot of adjustment I need to do, Jahnavi. Cancellation, lot of things I need to do here. Anybody who wants me to re-explain, I'm here. Jahnavi, should I re-explain this method?
Yes, sir.
Okay, Rujita, very good. Okay. Yeah, Jahnavi, whenever such equation is given, you try to take A, B, C, D beta. First step. First step is try to write A, B, C, D. Second step, whatever elements are there, I just wrote elements. I'm just making the equation. In nitrogen, only A into 1. Left side is only 1. But here, right side, 2C, 2 into C, 2C plus D into 1, D. 2C plus D beta, 2C plus D. Hydrogen, you can see 3A left side, hydrogen right side 4D, 3A equal 4D. Okay, chlorine left side 2B, right side chlorine D into 1D. That's all. So second step is finished, written equation. Third step, you can assume anything as 1. I have assumed D equal to 1. Why I am able to see D is repeating many places. So many calculations will be avoided. But you can assume anything, nobody is stopping you. I assume D equal to 1. If D equal to 1, what will we be? 1 by B equal to D by 2, B will be 1 by 2. If D equal to 1, what will be A? 4 by 3. Finished. Now, I already got A, B, D. Can I substitute here? A value, D value, I'll get C. So I just substitute A equal to 4 by 3, D equal to 1. I got C as 1 by 6. I just kept in place of A, B, C, D. But my particular final equation should be free of fractions. So I have seen 3 and 2 are there, 6 is there. Obviously, the LCM for 3 and 2 is 6. So I'll multiply with 6 on both sides. So that this fellow gets cancelled. 3 ones are 3 twos are 2 fours are 8 honestly. 2 threes are 6, 3 Cl2. 6 and 6 get cancelled. Only N2 will be there. 6 into NH4 is 6 NH4. So 8, 3, 1, 2, 6 is my right answer. 8, 3, 1, 6 is my answer. Okay, so student, again I'm saying there is no mandatory that you should use this method only. You can use any method. Okay, but please see this should be final. Number of atoms of all the elements should be balanced first thing. Second, there should be no common multiplier. Very, 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 very important. There should be no common multiplier. Many students will see that sir 4 to the 8 hydrogens, 4 to the 8 hydrogen, 2 to the 4 oxygen, 4 into 1 the 4 oxygen. Like that they will say balance, but it's wrong. There should be no common multiplier. That means you can take 2 common here. 2 into 2H2 plus O2. You can take 2 common here. 2 into 2H2O. So that this 2 and 2 gets cancelled. So your final equation should be 2H2 plus O2 equal to 2H2O.
Sir, when will we end the class?
7:45. Okay, 2H2 plus 2O2 equal 2H2. Okay, student. So this is balancing. Okay, so hold on, students. So one very important thing I need to say. Okay, very important thing I am just going to explain. So many students already just got disconnected. Okay, so student, you see, I have said when I was discussing how will you get full marks in chemistry. Every chemical reaction, you should always, every question you should finally end with a chemical reaction, chemical equation or chemical equation. But in that chemical equation, you should mention what are the states: solid, liquid, gas, aqueous. You should mention the states, and also you should mention the balancing. Balancing should be done. Okay, so balancing I have already taught you. These three methods. Give the first priority to hit and trial method. Second priority is ABCD method. Okay, table method, if you are comfortable, I'm not stopping you, go ahead. But you will be again many things you should cancel, rephrase the things back. Okay, so that's up to you. But sir, how to find which state is that? Okay, for that, you see, I have made the notes. So please try to concentrate here. Every reaction requires this particular concept. Every reaction, every equation you are writing in your chemistry. What is the trick? You see, student, most of the metals we have seen in the third chapter. Many metal, almost all the metals are solids. So whenever you are seeing the reaction, whenever you are seeing the reaction, there is a metal is there. You should write solid in it here. Okay, that means something like Zn plus HCl. If I take, what is this Zn? Zn is a metal. So generally at the room temperature, Zn will be solid. So you should mention yes over here. Understood, student? So most metal except mercury, which at room temperature it is liquid. You all know mercury. So you should mention solid. What else will be solid? NaCl, the salt, calcium carbonate. Generally ionic compounds will be solid. So whenever you are mentioning NaCl pure form, you should mention solid. Okay, this is another way. Okay, very good. Okay. Now, sir, who will be liquid? Whenever water is there, obviously at room temperature, it will be liquid. Bromine, being a non-metal, it should be in a gaseous form, but the exception we have seen. Bromine is an exception, being a non-metal, chlorine gas, oxygen gas, okay, nitrogen gas, but bromine is an exception, it's a liquid. So you need to mention whenever bromine is there at room temperature, you should mention liquid. Mercury, it's a metal, but you should mention liquid at room temperature. Okay, Rujita. Yeah, I'm coming to that point. Okay, gases, obviously, student, diatomic molecules, hydrogen, oxygen, nitrogen, chlorine, and some of the oxides, carbon dioxide and sulfur dioxide. Always you should mention gas. Okay, this is one thing. Okay, so what is next thing? Aqueous. So what is aqueous? So student, whenever ionic compound is soluble in water, we are writing aqueous. So NaCl, if I add water, what I am getting? NaCl only, but you will write aqueous. Why? It is soluble in water. Okay, it stays dissolved. And again, please remember, there is a very big rules which you will not able to remember so easily. Solubility rules, which will be coming in your higher classes, you will be concentrating more. But still, you need to use these rules. So some of the rules you try to remember the things. Water solid can be represented gas is upward arrow. Yes, obviously gas can be represented upward arrow and precipitate can be represented as downward arrow. Okay, yeah, so where we should write aqueous, sir? Obviously whenever ionic compound is soluble in water, NaCl, aqueous, whenever you're mixing with water. And generally nitrates, what are the nitrates, student? Like NaNO3, blindly mention aqueous. Okay, whenever you see nitrates, most of the nitrates are aqueous. That means they're easily mixing with water. Okay, aqueous. So when do we need precipitate? Precipitate whenever that particular they are not able to. I am mixing with water, but they are not mixing. They are depositing at the doubt. They are precipitate. So who is an exception here? Silver nitrate and silver chloride are insoluble. So please remember AgNO3, AgCl are an exception in nitrate. These are precipitate. You should show by this, or you can also show like this PPT, precipitate. Either you show down, it will be depositing at the bottom of the layer, bottom of, or you might mention PPT. Okay. General formula for nitrate. Okay, yes, you're right. NO3 minus 2, we say it. Okay. Yeah, there is a, yeah, you see, student, I'll post this particular thing. This is what the solubility. These are only 1% I took from solubility status. Whenever nitrates is there, they are always soluble. So whenever nitrate is always soluble, okay. I think there is an exception, right? Silver nitrate. 1 second, student. Silver nitrate. No. Okay, it's not a precipitator. Only silver chloride is present. Whenever you are able to see nitrate, please mention it is soluble aqueous. Okay, like that. There, I'll just send it in the group. You see, you'll be requiring this particular slide soon. I'm starting. So tomorrow we are starting this particular sample paper, right? In every question, you'll be requiring this particular slide. Okay. Okay. So tomorrow again, I'll discuss it. What is the next trick? Another trick is the student. Another trick, by the type of reaction you can guess. What is that? You see combustion. Whenever I write combustion CH4 plus O2, you see combustion means highly exothermic. That means that whatever compounds I am getting, CO2, gas. H2O, gas. You should not write liquid here. Why, sir? Combustion means highly exothermic. You are getting water, but that will be in a gaseous form. Okay? So by the type of reaction also, you'll get some clue. So what did I say, student? First of all, you try to see whether it is metal, non-metal or ionic compound. With that, you will get some trick. And if you are able to use solubility rules, that will be 100% absolutely fine. If you still not able to find out this by these rules, you see the type of reaction, combustion. Always you will be getting gases. Now you see single and double displacement. Take one example, Zn plus HCl. What is HCl here? It's a acid. So what should I write here? Aqueous. What will I get? ZnCl2 plus H2. Okay, so what should I write ZnCl2? Can anybody say what should I write ZnCl2? Yes, Mega. ZnCl2 का state क्या होगा बेटा?
The solid.
Yes, that means aqueous, right?
Yeah.
Yes, exactly. You see, student, so whenever you are able to see single and double displacement, try to use aqueous words. And again, you know, sir, why we are taking aqueous? Obviously, the electrons, the particular element should shift, some liquid should be there. Yes, so somebody is asking. Yes, Harshini?
Sir, but in double displacement, there is also precipitate, right?
Yeah, I'm coming to that point. Okay. So precipitate, what will you show, student? You see, let me take one double displacement. So Harshini is asking, sir, a double displacement how? Okay, let me take double displacement. Yeah, this is double displacement. You see double displacement. So I have not written the particular format. Huh? Okay, no problem. Lead nitrate. What is this? I should take aqueous. Do you remember, student, how did I take? Lead nitrate I have mixed with water. So the state will be aqueous. Lead iodide I mixed with water. That is what I said. Just now, what did I say? Whenever you are taking double displacement, probably most of them will be aqueous. Why, sir? Why they will be aqueous? The transfer of cations and anions should happen. How can the transfer happen? There should be some medium. That is liquid medium, aqueous. So whenever you are taking double displacement, that should be aqueous. Yeah, so definitely in double displacement, one thing will be aqueous, one thing will be precipitate. Okay, so what is this precipitate? Lead iodide is a precipitate. Because why? It will be depositing at the down layer. Okay, so whenever you are dealing with displacement, double displacement, ensure most of the things will be aqueous here. Usually occur in solution, meaning most of the reactants will be aqueous. So I'm not speaking about most of the products, most of the reactants I'm speaking. Understood, Harshini? Hello?
Yes.
Yeah, okay. Most of the reactants I'm speaking. Okay, sugar, NaOH is insoluble. NaOH is insoluble. What is insoluble? Student, Na alkalis are highly soluble in water. Their hydroxide also highly soluble in water, student. Okay, so NaOH, if you write, you should write aqueous. Okay, decomposition. So decomposition, how will it decompose it? Obviously, I need to heat it. You see CaCO3. How can it decompose to CaO plus CO2? I need to heat it. So whenever I am heating the thing, so obviously CaCO3 is solid. I need to heat it. Whatever I get, often involves heating of a solid to produce simpler solid. This calcium oxide is a solid and this thing will be gas. That is what he said. Whenever you are going for decomposition reaction like this, you need to heat it. So you are heating a solid. So solid you need to write. To produce simpler solid, you see CaO is simpler to CaCO3. And but you see something like gas will also be involved. Okay, so heating means some gas will be involved. Okay, acha, I said that, so then that's my mistake. So okay, so with the help of the types of reaction also you can guess who will be aqueous, who will be solid, who will be liquid. Okay, so shall we take one example and stop, student? Okay, do I have example? I don't have example. Okay, students, I think we are perfectly ready to start the sample paper tomorrow. Okay, so tomorrow will be the final session for this chapter. We'll be starting the sample paper, which we will be using all these concepts. Today, whatever concepts I give, this we will be using it. So when to say solid, when to say liquid, when to say aqueous, okay, and when to so by looking at the type of reaction also we can say some clues. You see, student, yeah. So you see, metals whenever taking, so final summary I'm giving, metals whenever you're choosing, try to take solid, like iron solid, copper solid. Noble gases, obviously they should be gas. Acids, HCl, H2SO4, whenever you are taking them, you should take aqueous. Why? Because you are making dilute by adding water. Okay, adding water, you are making dilute in many reactions. So obviously that will be aqueous. Insoluble solid, obviously you should write solid, or precipitate also is fine. Okay, like PbI2, solid, and like this precipitate also, because it is depositing at the bottom. Okay, okay, so soluble salt, yeah, I said every nitrate or ionic compounds are generally soluble. You need to write aqueous. NaCl, it's an ionic compound, it is generally soluble in water. You need to write aqueous. Okay, so one of the, who is the student? Rujita, is it you asked me this doubt?
Yes, sir. Thank you, sir.
Okay, so yeah, so student, I think I have cleared 80% doubts. Tomorrow when I go for the session, I'll be clearing remaining 20% doubts, student. Okay, when to take solid, when to take liquid, when to take aqueous, those all. Okay, yeah, that's all from my side. Thank you for joining me. I'm a little bit late today, 10 minutes. Thank you. So Punappa, are you there? Okay, thank you. Punappa, are you there, student?
Thank you,
Punappa is not there. There.
Thank you, sir.
Thank you, student. Punappa, are you there, student? Yeah, thank you.
Thank you, sir. Bye.
Bye, thank
Bye.
you.